So in this video we can have to discuss about the free fall motion. So a free fall motion is a part of motion where the object is moving in a one dimension or in a one axis. So it is also part of the linear kinematics, only that this motion is where the object is moving along the vertical axis or along the y-axis. While the motion we have recently looked up to, that is also part of the motion, is the motion where the object is moving along x-axis. So take note of that. So what is a free fall motion? Now let's say we have this case. Let's say we have the two objects. Let's say we have a paper. Let's say this is a paper. And we have, let's say, this is a stone. And let's say these two objects has been released from the top of a building or whichever part from the top. And now, this is a paper. And we know that the paper is more lighter than the stone. Let's say this is a paper as I've already specified. And let's say this is the stone. So now, there is a presence of air particles in the atmosphere as the objects are falling down. So now, due to the presence of these air particles in the atmosphere, the falling of these two objects will be affected by those air particles. In this case, a paper will be highly affected than the stone because the stone is more heavier than the paper. And even the surface area of the paper is more larger than the stone. Therefore, this one will have to experience more friction force than the actual stone. You see that the stone will have to run faster than the paper because of the difference in the air resistance. So a stone being heavier and has got the small surface area will have to run faster than the paper. So on the ground level. So you see the stone falling faster than the paper because they are actually differently affected by the air resistance. So that's the case. So which means they will actually differently accelerate. This one will accelerate less, this one will be accelerating more because they are actually different in masses as well as the surface area. So now, assuming that now these objects now are in a vacuum where there's no air resistance. So what's that? Now, if now these actually objects are in a vacuum where there is no air resistance. Now, upon releasing the two, we'll have to get land on this. Actually, we'll have to. Upon releasing the two, we'll get landed at the same time. So a paper will land on the a ground. At the same time, the stone will also have to land the same. Actually, will have to land the ground at the same time. In other words, they have the same acceleration. Now, despite they differ in masses as well as the surface area, but since there's no air resistance in the vacuum, then the objects are going to have the same acceleration. So what is that acceleration? It is acceleration due to the gravity. The only force these two objects are going to experience will be the gravitation force. That will be equally experienced. So these objects are going to accelerate at the same time. They'll have the same acceleration given as a g is equal to 9.81 meters per second square. So since they'll have the same acceleration, means they'll have to land on at the same time. So what is a free fall motion? This is the falling of the object. This is the falling of the object under the influence of gravitation force only, with no air resistance. So that is the free fall motion. That is the falling of the object without the air resistance. So that's the free fall motion. And this one was discovered by Galileo Galilei, the one who invented or the one who discovered about the free fall motion. So whenever the objects are falling down, acceleration due to the gravity is actually positive. And whenever the objects are going upwards, it means we'll have the negative acceleration due to the gravity because the object is against the gravitation force. So take note of that. And now from the fact that under the free fall motion the objects tends to actually move at a constant acceleration, which is the gravitation which is acceleration to the gravity, then the equations of motion that we recently discussed about will be incorporated. Mind you, those equations of motion are kept on hold under the assumption that the object is moving at a constant acceleration. Hence, free fall motion also have to incorporate the same equations. Now, you should have to understand that on how you should be able to transform those equations to be now that in the free fall motion. Now, whenever the object is going downwards, let's say the object is falling down. In that case, acceleration due to the gravity is given as a positive g is equal to 9.81 meters per second square. That is whenever the object is falling downwards. And what is this according to the equations of motion? So which means we'll have a v is equal to at plus u, where there is acceleration we are going to have a g. So now we'll have it as a v is equal to negative gt plus u, and also have s is equal to ut plus half at square. Now since this is the vertical motion, instead of having since this is the vertical motion, now we'll have this one as this. So now we'll have it as now displacement is equal to ut plus half a g square. Of course, displacement is the same as height. Now since this is the vertical motion, instead of having the displacement, we'll have it is in form of height, but it is the same. Where there is acceleration, we're going to substitute that of actual g. That is when the object is falling downwards. And I also should have this equation as well. That is a v square is equal to u square plus 2as. Now have it as a v square is equal to u square plus 2gh, or just have ac is the same, where this is the height. So that is. So whenever the object is falling down, the following are the equations we have recently discussed about, which have to transform from the equations of motion. Mind you, we said the final velocity is equal to negative g, should be positive. So should be a positive gt plus u, and I'll have v square is equal to u square plus 2gh, where this is the displacement of the height, and also have height is equal to ut plus half a g square, like that. And I also have this case as well, if we had used the following formulas as well. The displacement is equal to u plus v over 2 in that times t. You know where this formula is based from. So bear that in mind. That is for the object which is falling down under free fall. So have that and as that. And whenever the object is now moving upwards against the gravitational force, let's say the object is now, should be this. Let's say now the object is moving upwards like that. So which means acceleration to the gravity will be negative 9.81 meters per second square. So in that case, we'll have v is equal to negative gt plus u, and I'll have now that of v square is equal to u square minus should be 2gh, where this is the displacement, now it is height, and I'll have height is equal to ut minus half actually a g square. So these will be actually equations to use whenever the object is moving upwards. Now have the acceleration that will be negative. So that is. Now, of course, we also have the case where the object is now being released from. Of course, we also have the case where the object has been released from the ground level and up and back to the ground level. So that is said to be ground to ground, actually ground back to ground case. So in this case, overall acceleration due to the gravity will be given as the negative 9.81 meters per second square. So that's the actually for the overall analysis we'll have to use actually negative g. And where we also have the case where the object has been released from the top of the building, we also have the same analysis as well, as we're going to see that one up to. Let's say the object has been released from the top of a building. Let's say this is the ground level. Now the object has been released from the top of the building and it goes back in this case. Now for the overall analysis, we'll have also negative 9.1 meters per second as the acceleration due to the gravity in that case. So next we're going to see on how we can be able to analyze all these cases and actually step by step, and for the sake of actually mathematical calculations or analysis of the free fall motion. So we have to look over on what you call way up motion, where the object has been released from the ground level and up, and I'll have the way down motion where the object has been released from the top and down, and also have to look at the ground back to ground case where the object has been released from the ground and back to the ground. And finally we'll have that case where the object has been released from the top of the building and up then down. That is said to be a top up ground case. We are going to discuss all these things and for the upcoming lessons, but just have to know that the free fall motion is the falling of object actually without the air resistance, under the influence of gravitation force only. So whenever the object is moving upwards, it means we'll have a negative a g. Downwards we'll have the positive g. So take note of that. So objects will have the same acceleration due to the gravity despite their masses. No matter how heavier the one can be, but they'll have the same acceleration.